Hello everyone, I'm Pramika Garg and I'll be talking about Platform as a Service PaaS mechanisms today. Services come in three different tiers dictating how they can be offered. There are many different varieties we could choose from. The most common right now is the on-premises type structure. On-premises solution is where all the servers and their hardware and all the management of the software is done in your own physical location. So the engineering team of that company will have full physical and virtual control over the servers as well as this. Next up on the ladder is using infrastructure as a service, or IaaS in short. This is a service by which the company doesn't set up its own physical hardware. Rather, it contracts other company to give their physical hardware, which is made directly available from that vendor to the company. The vendor does not provide any software or top of the hardware. They just provide a bare metals interface. On top of all of this is something known as Platform as a Service, or PaaS in short. This type of architecture is when the vendor's engineering team not just provides the physical hardware, but it also provides a software layer which is based on top of that hardware, which includes things like runtime, middleware, etc. So this is the infrastructure that is ripe and ready for deployment of any application as the infrastructure is fully managed, the physical aspect as well as the OS and other middleware, etc. All of that is directly managed by the vendor itself, and only the application and its data needs to be managed by the company. We need to look at many different types of services that all of these three different levels of abstractions they have. Let's try to compare them. So first of all, let's define the services. There are multiple services. Looking in at the networking service. So what is the networking service? Suppose you have two computers around the world. How do you connect them to each other? It is using something called a network. So similarly, network is used to connect many different servers together, whether they may be internal, external, etc. They may also be used to connect routers, firewalls, access points, and even the cabling used for physical connections. All of these devices and the cables used together from the networking service. The next service that these providers provide is called storage. So anytime we have any data that we are looking at on a laptop or on a cloud server, all that data has to be stored somewhere, whether it's the website, browsing, or the app we are looking at. All of that has stated that's stored somewhere. So all of that data forms collectively the storage section. It could be in any number of files in different folders. It can be databases, blocks, objects, etc. The next aspect is the server architecture, the bare metal server architecture. That is basically the server system, the motherboard, the CPU, the RAM, as well as power systems and fans. The things like that. The physical machines without any networking of storage or additional GPUs of things like that. That's the server. Next step is virtualization. Virtualization is the abstraction of physical hardware into virtual hardware. Suppose you have a server with 64 cores and you want to run 16 desktops at once. Maybe let's say multiple desktop instances on that one CPU. So it's going to be very hot unless you buy multiple CPUs. So what's the alternative to that? Suppose you just need 4 cores for each desktop. So what can you do is you can create 16 virtual environments where basically you will have a simulation of 16 CPUs. Simulation of 16 CPUs, and all of those 1/16 of the main 64 core CPU will be piped from the main 64 core CPU. So there is a similar method where we can virtualize other hardware here. I just talked about the central processing units, but the same thing can be done for any other thing. Like for example, it might be the power delivery or GPUs or the storage or any networking capacity. So all these things can be used to be virtualized via software/hardware system called hypervisor is used. The next thing went up, there is something called the OS or operating systems. So what is that? Operating systems are basically pieces of software that connect our applications for lower level user applications down to the hardware. For example, you might have all used OS X, that is Mac OS or Windows, or some might even be aware of flavors of Linux or BSD. So those operating systems let us use our applications by connecting them to the hardware. Next thing, one is something called middleware. So what exactly is middleware? It is comprised of API endpoints and other endpoints, data points, that allow you to build an application for a specific operating system. For example, if you want to store a file on Windows, you will have to use API that is created by Windows for storage management. So that needs to have some configuration. How will the application contact the OS, and how will OS process that information? So for that, application needs to have some standard endpoints which can connect to the OS. So this is what it is known as the middleware. Next thing we are up to is something called the runtime. Runtime is basically the system holding the state of an application, whether we run a web browser or any other program. For example, if you're running Java programs, we use JVM, Java Virtual Machine. There are alternatives that exist for all the other languages or any other application that needs to run. It stores the state and perform operations and transactions on data. We need something called a runtime which stores the execution, a context of an application, as well as performs any necessary operations for the smooth functioning of any application. The next aspect that is something called the data. In data, we will be looking at different forms of storing information. This can be something as simple as text files, or it can be complex databases such as MongoDB, MySQL, PostgreSQL, and many more. Next step of the line is the application. An application will contain all of the systems and services needed for that application to perform its business function. Essentially, it contains all of the business logic of a product. So we have found that we have these services. Now let's look at which of these services do we have access on different cloud computing offerings. When it comes to on-premises, we can choose and decide all of these. We can tweak our networking, storage, servers, virtualization, operating system, middleware, runtime, data, applications completely. It's completely dependent on us. Next is infrastructure as a service. So what is that infrastructure as a service does? It still allows you to have control over your application, data, runtime, middleware, and operating system. But the first four parts, the physical servers, the storage hardware, networking connections, the virtualization of the system, is controlled by the IaaS, provided you do not have to work with them directly. In the next set of at this platform, as a service is basically, you do not have to worry about much at all. It's the easiest to get set up with. It doesn't take any time, so they will handle the networking, storage, servers, virtualization, operating system, middleware, and even talk to the runtime. So that really, what things you get? What about one is data that is the error that your application might generate or use a store, and even there are some attractive services they provide for that as well. And for applications, we need to develop the business application, business logic for your application and use it accordingly for the product. So now that we understood all of these different offerings, let's look at some advantages and disadvantages of all of these. Let's first of all analyze on-premises solution. So what is the advantage of using an on-premises solution? On-premises system allows for granular control. It allows for full detailed control over all aspects of data as well as software. It ensures the security of operation is much better because the hardware is physically in control with you, the company, and you have the ability to change anything and everything you want. But then it brings with it a series of responsibilities when you will also need to worry about the hardware and scaling. There's networking and virtualization to be set up among other things, which takes time to set up, periodically expand and test. It needs experienced professionals to work and increases the costs via a larger engineering team. IaaS is basically a system where you have the hardware and virtualization provided to you. So in this case, you don't need to worry about those things, but still you need to work with many other things like operating system, middleware, runtime, plugins, data, and of course your business logic, that is your application. You will set up endpoint services on your system, such as messaging, transactions, etc. You will have to set up on your own. It does give you a bit of less work compared to on-premise, but then it removes some granular control as well. You do not control how the virtualization works, how much storage, networking, and servers are physically allotted. You cannot control them much. You're not able to control the CPU is that you use or the GPUs, at least not down to granular level. But then it does allow you to get ahead and get started on a project faster comparing it to an on-premises system. Next, we come to something called PaaS or Platform as a Service. This is by far the fastest setup. It's much easier to work with and it can be scaled very quickly. It does not love for any granular control over any aspect other than the data and your application. So you do lose a lot of freedom, but with lesser responsibilities and much better time efficiency. Over here, you get logged into the operating system or to specific hardware providers like CPU architecture, for example. You get logged into that, and in both IaaS and PaaS depends on it. You might be worried about the security of the data that you're holding over there is in the end. The hardware is not with you. It's rather in the hands of some other company or your vendor. So there are some disadvantages as we move from on-premises to PaaS, you lose granular control, but you gain in reduced complexity and increased scalability. So I hope this clears up platform as a service, PaaS, infrastructure as a service, IaaS, and on-premises solutions for you. Thank you very much for joining in. It's been wonderful helping you all. My name is Pramika Garg, and this is part of the Udacity SUSE Cloud Foundation Scholarship Program. Thank you.